This is part 1 of lesson 6 of unit 8, volumes by disks and washer methods. So we've used integration to evaluate areas. We've also used it to find volumes that have a particular cross section. Now what we're going to do is we're going to start revolving graphs around an axis of revolution, and we're going to look at it first as what if this solid that's revolved looks like a cylinder or a disc. And then what we're going to do is we are going to look at it, what if there's a hole in the middle and it becomes a washer. So we're going to start by looking at this graph where we have a line graph, x plus 3y, and we are going to rotate it around the y-axis. So when we do that, we are going to get the shape on the right. We're going to get a cone because this shape has a top right here, and we're going to be revolving it around this way, and as it revolves around, it is going to go around like this, and depending on where you are on this figure, you're going to make smaller and smaller trips around the cone till you get to the point where you hit the y-axis. So to find the volume of a cone, we could just use the geometric formula 1/3 pi r squared h, or 24 pi. But it's not always that simple, so let's come up with a method that'll work for a shape that isn't a line when we start. So what we want to think of is, what if we just take one strip or a disc that is created right here, so like this, that has a radius of x, so the distance from the y-axis out to the edge of the disc, and its thickness, or its height, is that change in y, dy here. So you want to remember that the volume of a cylinder is pi r squared h. So this becomes, our dy becomes our h, and our x is our r. So that's where that formula comes from. So the cone can be created by doing an infinite number of these horizontal strips or discs, and they'll get smaller in x values, so smaller in radius, so eventually they'll form that cone on top. So that's what we're going for. Okay, so what we're supposed to do is write the volume of a cone as an integral on the interval from 0 to 2, then find the volume of the cone. So we're doing this, the cone we're doing is the one we looked at above. So these are y values here. This is my y values here. So what we want to notice is that we should get, when we're done, 24 pi, because that's what we would get if we just used the formula with this radius right here of 6. Sorry, this radius of 6 and this height of 2. Okay, because we get 1/3 pi times 36, and then so that would be 12, and then multiply that by 2, and we get the 24 pi. So let's see if we can do that using our disk there. Okay, so we are first going to write the volume formula. So V is going to equal the integral from 0 to 2, because that's where it hits the y-axis, of pi times our radius squared, which is x, times dy. Now we have a problem here because we have an x and a dy. Now remember, the equation up there was x plus 3y equals 6. So let's solve this for x, and we get x equals 6 minus 3y. So that's what we're going to substitute into our integral. And now our integration is in the right variables. So this is going to be pi times the integral from 0 to 2 of 36 minus 36y plus 9y squared dy. So when we integrate this, we're going to get pi times 36y minus 18y squared plus 3y to the third, and we're going to evaluate that between 0 and 2. So our volume becomes pi times 72 minus 72 plus 24, and we get the answer we were looking for, which is 24 pi. Okay, so this, as I said, is called the disk method. When you find volumes of a solid of revolution, it is important to focus on what happens to each individual slice or disk as it's rotated around the line, instead of thinking about the total volume. So what we're looking at is one little disk here. It's sliced vertically. The volume is pi r squared w, or h, depending on what nomenclature you're used to. So the volume is the area of the disk times the width of the disk. And our width is going to be our infinitesimal value. That's going to be our dx or dy. So in this case, it would be dx because it's a horizontal rotation, so it's going to be the x-axis. So that's what we're getting at here. If we have a horizontal axis of revolution, you solve for y in terms of x, so your volume will be that formula. The integral, pi times the integral from a to b of r of x squared dx. So that would be your radius. And if it's doing the revolution around the y-axis, you solve for x in terms of y, and so your radius should be in terms of y. Okay, all right, let's do a couple of examples here. So example 2 through 5 says set up and evaluate each integral that gives the volume of the solid by revolving the region about the x-axis. So let's sketch our picture first. We have the line negative x plus 1, so the shape will look like this. It's going to look a lot like the one we did before, but the difference is we're revolving it around the x-axis like that. So here is going to be the radius of each of our disks. So if I draw a disk here, each of these are going to be super tiny, and so my r here is going to be y, so that's going to equal the negative x plus 1. And my h, or my w, is going to be my dx here, this width right there. So I can set up my volume now. So my volume is going to be pi times the integral, and so we're going from 0, and this hits the x-axis here at 1. So from 0 to 1 of my r squared, 1 minus x squared, and then my w, which is dx. So multiplying that out, we get pi times the integral from 0 to 1 of 1 minus 2x plus x squared dx. Integrating that, pi times, so we have x minus x squared plus 1/3 x to the third, evaluated between 0 and 1. So we're going to get pi times 1 minus 1 plus 1/3. So we're going to get, for volume, pi over 3. Okay, next example. Now we have the square root of x. So drawing that and getting a visual of what it would look like, square root of x looks like this, and we're revolving it between 0 and x equals 4. So our little strips are going to be here. They're going to be super skinny, so they touch. So now my r is going to be my y again, because we're revolving it around the x-axis. So that's going to be the square root of x. And again, my width of that is going to be dx that way. So my volume becomes pi times the integral from 0 to 4 of r squared w. So v is going to equal pi times the integral from 0 to 4 of x dx. So we get v equals pi over 2 times x squared from 0 to 4. So we get pi over 2 times 4 squared. So we get 8 pi. Okay, for number 4 now, this one is a little different. We're going to revolve it around the y-axis. So we're going to see both sides of this parabola. So now we're revolving it this way. Let me draw that, see if I can draw that a little more symmetrical, because we can almost see the shape here. So now we are going this way around the parabola, swinging it back around. So you're going to see this shape here. So you're going to kind of see it here. So it's all of this filled in here. And so now our R is here, from here to here. There's our R of X, because each of our little discs are going to be real skinny like this. And so our R of X is going to equal, has to be equation of X. So if we solve this for X, we're going to get Y equals X squared. So X is going to equal the square root of Y. So R of X is going to equal the square root of Y. I'm sorry, I did that completely backwards. I apologize. I'm going to solve that for X. So I have, yeah, no, I'm good. I'm looking at the wrong problem. I was looking at the previous one on my paper. I apologize. So that is correct. Okay, so the other thing that we do know is now we have our dy this way. Our dy is here now. That's our h, our height, our width. So our volume is going to be pi times the integral, and this goes to 4. That's going to be how high up we are here. 0 to 4 of our r squared, so that's going to be the square root of y squared, times our width, which is dy. So that's going to give us pi times the integral from 0 to 4 of y dy. So v is going to equal pi times 1/2 y squared, and that's evaluated between 0 and 4. So simplifying this, we're going to get pi over 2 times 4 squared. So we get 8 pi. Okay, so you guys try the next one. I'll draw the picture here, and then you see what you get. So now we have e to the x, which would look like that. It crosses the x-axis at 1, and we're revolving around the x-axis, and we're going from 0 to 2. So here's where we're at. So here's where the little disc will be. Okay, so we have, this is our r, this is our dx. Okay, and what you should get when you do this one and simplify it, you can just leave it in this form, pi over 2 times e to the 4th minus 1. So see if you can pause the video here and do this one yourself. Okay, I'm going to stop here, and then I am going to, in the next method, do the washer method.